Let's take a look at number 5 now. So, and there's basically three cases here. That's why I'm showing you three examples. So the first case is where you're given two angles and an opposite side, right? So I'm given angle B, angle C, and I'm given side B, and so that's pretty straightforward, right? We can, that sets up very nicely to find side C, and then we can go from there to find everything else. Here we're given angle A, angle B, but side C. So this is not. It's not the C is not an opposite side of any of those angles, right? But that's easy to remedy because if we're given two angles in a triangle, we can always find the third, and so that's pretty easy to do. So that's what we'll do first here is we'll just find angle C. So angle C is just going to be, and you don't have to show the work for this, but it's going to be 180 minus 50 minus 30. So that'll be 100, right? So that's one thing. So we found one part of our triangle. And not only that, but now we set it up to where we can use the law of sines, right? So I know the law of sines says sine of an angle, let's use 100 here, over its opposite side, right? So I'm matching up C with C, angle C with side C. So now equals, so now I can use either A or B, angle A or B to find side A or B respectively, right? So let's start with A. And so we'll do sine of A, which is 50 over little a, right? Okay, and notice I'm not drawing the triangle this time, but if it helps you to draw the triangle, you definitely can. And then be careful with this. This is a big issue sometimes, like A and 9. Make sure those don't get mixed up. All right, so now I'm going to cross multiply. So it's going to be A sine of 100 equals 9 sine of 50. Then we'll divide both sides by sine of 100 to get A by itself. And so we'll end up with A is approximately, plug this in your calculator, and I got 7.0007, so it'll just be 7.0. And you could just put 7, but adding, including the 0.0 gives you, it shows that you have more precision than if you just put 7. So this shows that you're precise to the nearest tenth. So, but either way it works. All right, and then last I need to find side B, right? So I know all the angles A, B, and C. I know side C was given, side A we just found, so now I need to find side B. So I'm actually going to have this, I'm going to use this again, sine of 100 over 9, but instead of sine of 50 over A, now I'm going to do sine of 30 over B, right? So I'm going to do sine 100 over 9, because those are the two parts that we know exactly, right? Those are the opposite pair that we know exactly. Then I'm going to do sine of 30, right? This, using that angle there, over little b, which is opposite of big B. So then same thing, I'm just going to cross multiply. So we'll get B sine 100 equals 9 sine 30. Divide both sides by sine of 100 again. And we plug that in our calculator, and we get B is approximately 4.6, approximately, right? 4.56 is what it was, so it rounds to 4.6. We don't have any units for side lengths, so don't forget your units for degrees or for angles. Make sure you put degrees. Okay, so with solving these triangles, usually you'll be finding three parts. There usually will be three missing parts. So we found all three. And so that was a kind of a case 1B where we were given two angles and a side, but the side wasn't opposite the angle, so we had to find the angle first, and then we're able to find the sides. Okay. All right, and then we can double check that the largest side 9 is across from the largest angle 100. The smallest side 4.6 is across from the smallest angle 30. So that makes sense.